1x squared. Yeah.
Okay, so looking at this expression, so this is out of 1.6. So before I go on to this particular practice problem, are there any questions or comments about this idea here? The goal was to have you think outside the box. Yes.
Would this be like a quadratic equation? Is that one of the
More than likely what this might be, we could write this particular example as f of x is equal to 1 over x minus 3 for x is strictly less than 3, and f of x is equal to 2 for x greater than or equal to 3. And so this is how we might define this particular piecewise differential. And maybe one last comment about Arthur, you had a question about left versus right limits. I could think of an example here where our left and right limits are in fact maybe both positive infinity. And maybe right on the vertical asymptote, my function is defined as f of 3 is equal to 2. So here I could still have the same limit on both sides, but still have our function defined on the vertical asymptote. Okay, other questions about this thinking outside the box question? Okay, so then there was a question about these rational functions and dealing with limits involving rational functions. And so, Aaron, you had asked about this one, and so when I look at something like this, the very first thing I want to do, because it's not necessarily immediately obvious when I look at a rational function whether I'm going to have a vertical asymptote or a hole in the graph. And the way that we can tell that, and so those are really going to be the only two options with a rational function. We get a hole in the graph when we have 0 over 0 at the x value, and we have a vertical asymptote when we have a non-zero number over 0. And so I might do my quick check over here of 2 minus 1 over 1 minus 1 squared, and I'd end up with 1 over 0, which would tell me that I'm not going to be able to do any algebra. Only if I can do algebra if and only if I have 0 over 0. And so when I have something that is non-zero over 0, then my algebra fails, and I have to go to plan B, which is either graph the function or plug in x values close to 1. And so in this case, it's probably easiest to graph the function.
And that's what I was asking, because it just seemed like there wasn't really anything else to do.
Yeah, there really isn't a whole lot else to do. In terms of how you would present something like that on an exam, for example, what you might do is, if you look at this problem and say, okay, I realize that I'm not going to be using any algebra, and instead you might want to actually draw a picture of this function and have it, so you've got a picture there, so I'm going to peek at it.
Yeah.
Okay. That one more time. So, again, put it upside down. There we go, much easier. Thank you. So something along the lines of this picture.
Close, yeah.
Okay. So we would want to include a picture of y is equal to 2 minus x over x minus 1 squared. And once I have a picture, then I can say, okay, this limit is equal to infinity. The limit as x approaches 1 of 2 minus x over x minus 1 quantity squared is equal to infinity. But if I'm going to use the graphical method, that I definitely want to include a graph in my supporting work.
One's going, like, if one of the lines is going to negative infinity and one's going to positive infinity, does that make that make sense?
Yes, that's correct. Yes, so if your supporting work gave branches that went in opposite directions, then your limit would not exist. And you'd still want to have your supporting work. Okay. Okay, are there other practice problem questions out of 1.6?